So see, Docker architecture, we need to understand the components clearly, how each and every component work, because we can install all of them, all the different components in the same server or same desktop, same laptop. We can install all of them, but there are different products that the Docker as a company they provide Docker CLI. That's where you can do the build, you can pull the image that you want, you can run the container using that Docker CLI. And the exact place where exactly the Docker container runs is the Docker host, the Docker daemon. So without the Docker, see, Linux, right? So the daemon is the background processes or a process that runs the actual container. So Docker D is the daemon background process, which allows you to run the containers, which allows you to store the images, which allows you to use the network, access the storage. So all these things are managed using the Docker D daemon. And Docker Hub is where you store the created images, store the created packages, and all those things. And you can also do tagging, version control, all those things to show like which version was created recently and how you are evolving. That can also be done using Docker Hub and the Docker, they call it as Docker Registry or Docker Hub. And Docker D is also called as Docker Host, and Docker CLI is also called as Docker Client. So there is a client, there is a server, and there is a separate registry. These are the three high level component, and between the Docker CLI and the Docker server, it uses REST API commands to connect and do all the activities. And from the Docker daemon or the Docker server or the host, to connect to the registry, it's a kind of pull and push command that we use to push the image once you make any changes, or pull the image when it is needed. You can pull it and run it. So the CLI never touches your container directly, right? Every command becomes a API call to the daemon. It's a REST API call, and which is why we have a separate Docker host server. And then you feel like it's working on the same hardware, but it is actually two different area. Okay, so the daemon generally runs on the Docker hardware itself, Docker server itself. And from the Docker CLI, we generally use these three common command. There are few more additional command, and there is another concept called Docker Compose. We will discuss maybe after a week, because that's for multi-layered containers and so on. So you can actually pull the image and run it as a container. So when the image is running, it is called container. When the package is stored in the registry, it is just called a image. Okay, so that's a different container getting stored as a kind of package on the registry, it is called image. And when the same container package runs, it is called containers. Okay, so that's the main difference. And we will see there is a color um, coding that I have clearly given how the uh, pull works, how the run actually works. So whenever you run a Docker run command, it checks for the image and then it runs as a container. Similarly, whenever you're pulling the image, so you have to pull it from the Docker CLI command, and the Docker daemon is interfacing for every single thing that you do. Without going into the Docker daemon, none of the command works. So it goes there first, and then from there, it goes to the Docker registry, and then it comes back, and then it runs actually. So that's how it generally works. Okay, so this is the flow. I think this is also a slide which I already touched upon, where exactly we are currently using containers in a real production environment. So these are some of the common aspects, right? Even on the data platform, even on a lot of development and testing environment, container is a easy way to do the testing and application development, because it's easy to port, it's easy to run anywhere once it is really tested and done. Okay, so there are some misunderstanding and myths with some of us, and we'll get to understand the actual fact. I already touched upon few points here. Docker is a company, Docker is a tool, whereas container is a concept. Okay, container is something which run on the Docker platform, and container and Docker is not the same. Okay, so Docker is a different thing. It's a tool, it's a platform, it's a company, whereas container is a concept. Number one thing which you need to be clear of. And containers and virtual machines are not same, they are different. And I already explained in detail how they are different from one another. Virtualization is different, containerization is different, and there are quite a lot of benefits on containerization, because it is a fast start, it is very lightweight, it has a very efficient resource usage, and you can run hundreds of container where only 10 VMs was running earlier. Okay, and the other thing is, people think container is unsafe. because of the reason they share the same OS kernel, and the processes on the OS level is not kind of separated. So people think this is a kind of problem. No, it's they're really not like that. So containers are definitely isolated, and it is very much controlled. And containers still use the Linux kernel feature, and we still capable see these concepts were there for 30 plus years actually. C group, namespaces, and all those things. They are very good options, features which can be used for having a very good strong isolation that is still being leveraged by the Docker product. See, Docker at the very high level, you might feel like it's a separate product. In fact, it still leverages some of the core key features and capabilities coming from the Linux OS, like the namespaces, C groups, and even some of the run C, all those things, right? So they are leveraging it, and definitely you can have resource limitation. You can isolate the process at the network level, at the compute level, and even on the storage level also you can have isolation. And you can also have role based access control. You can give limited privileges for specific containers and so on. And you can also do a scanning, updates, checks. All those things can still be completely controlled and secured. So production environment is actually, see, that's the reason many companies are using it, right? It's not that they have not used. So many uh, almost 80% of the Fortune 100 companies, they still use containerized workload, especially on Docker. Okay, so it's Docker is not just for the big companies. Okay, it can be for small startups also, and even a lot of modern applications from the enterprises. They run the Docker containers for their mission critical production workload. So at a very high level, containers are really portable. They consume very less space. They are very fast. They are very agile. They take very less time to start the application, and it is consistent wherever you run, and it is efficient. It is scalable. You can create as many containers as you want based on the real need. Okay, this is something I already explained. So there are three layers: client Docker CLI, and we have the server Docker host, and you have the registry where you pull the image whenever you want to run that as a container. You pull it from the Docker Hub or the Docker registry. So this is the high level architecture. And any questions on this one? This is a kind of three-layered architecture. You have a client and server, and also you have the supporting registry, which we call it as Docker Hub. So this is the high level architecture. Yeah, go ahead.
Can you just explain in a short way? Like I missed it.
Which one?
Just the architecture. This architecture.
No, it's the same, right? See, I explained it here. It's the same three tier. Okay, so you have a Docker client from where you do all the pull, push, and run the commands, and the Docker daemon is the this where you run the server. That is what we call it as Docker host. That's where your actual container runs, and the Docker registry where you store the packages and images which you want to run as a container little later. So for that, we have different toolkits and stuff. So we are going to learn all those Docker build, Docker run, Docker PS, Docker images, compose. There are quite a lot of commands that are available, which we are going to show in practical. Okay, it's the same architecture which I explained earlier, and so it's the
Okay.
Docker CLI is the command line. It's the client. Docker host is where the Docker daemon, Docker D runs, and registry is where you store the images and pull it.
Yeah. Yeah. Thanks, Tim. Yeah.
Yeah. Someone else also started speaking, I guess. Okay, see, there are additional aspects on the image side. So you can definitely have Docker images as a public repository. You can also have a private repository. You can also have an official image. You have classifications there. You can go and use the verified publisher and all those things. And also it supports webhook and other things. You can easily pull, push, and there are privacy options there. And see, you can access it from anywhere you want, right? You can quickly pull them, do the fast build, and you can also have catching also can be shared at the hardware level, right? You can have multiple platform, and multiple teams can connect to it, and they can do a parallel execution and run it. So currently Docker BuildX, there is a tool called Docker BuildX, and we'll get to see that. So you can use it for building images for Linux container, Windows container, using the same single tool. And Docker Scout, I told you, right? It is also getting very popular. Did I have somewhere? Not sure if I had Docker Scout. Yeah, so Docker Scout is not mentioned here. See, Docker Scout is a very good product which many companies are utilizing it. I don't know what is the reason I missed it. Okay, so Docker Scout is another very good product which is used for vulnerability scanning, and it can scan for any CVE detection, and also it can give you quite a lot of recommendations for your base image, and also it can do SBOM analysis, policy enforcement, continuous security monitoring. It's a security product, Docker Scout. Okay, so that is another product which I missed. Yeah, go ahead. Someone has come out of mute. SP, any question?
Okay, no, just I unmuted, but I have one doubt.
Yeah, yeah, go ahead. Yeah,
So,
yeah.
okay, for example, Stan,
Mhm.
so before cloud in on-premise, we'll be having a Glassfish server as a setup.
Okay.
Then we'll be building the Tart package of application and deploying the Tart package into the any one of the application server, and we'll do some testing, right?
Hmm.
So if we have any issues, we can open or we can download the Tart package and see that how the code looks, whether any confusion is there, any
Hmm.
mismatch or something. You can see in the actual deliverable package itself.
Hmm.
Okay, so like that, can we do anything in the application image? We can
Okay.
whether we can able to download and
Mhm.
see how the content looks like. Suppose if you are changing any configuration file, whether the changed content is there or not, like that, whether we can able to see here.
Okay. See, the development experience has enhanced, has evolved. Okay. So earlier, we used to have, for example, for Java, generally people might use Eclipse, and for .NET or other products, generally they might use Visual Studio Code and other tools. So all those tools still capable of accessing the container image, be it Eclipse or IntelliJ or Visual Studio Code, can access your application code. And in fact, it can also go and access the dependency files, the additional things that we have added into the package. You can definitely do all those things using the same tool that we have been using as a developer tool on the premises. It's the same tool that can be still used. So those tools are also evolved to access the container image and modify them. And I mean, Docker as a company, they have developed multiple tools. Like BuildX is one of the tool which can be used for opening and seeing the content, make some changes. So you can use Docker inbuilt BuildX tool also. And Docker has also introduced one more tool recently called MCP Toolkit, which is mainly for AI related workflows. If you want your application to connect to maybe, let's say, our external tool, like say, let's say Gmail or Splunk, or maybe your what do you call, there are quite a lot of tools, right? Like if you want the application to connect to SharePoint or Confluence or Jira or ServiceNow or whatever, so there is a toolkit called Docker MCP Toolkit, which can also be used for integrating your application to different external tools, external applications which are readily available. And it also has a tool to make changes into your application code also. The BuildX tool can also be used, and there are quite a lot of other extensions and other things which can be used as a developer platform. So Docker has its own tool. BuildX is there, MCP toolkit is there, and if it's a very small change, you can also use the Docker build command also. So that can also open up your file. You can use the VA editor or Nano editor within your OS and start editing those files within your operating system itself if it is a very small change. But if it is a bigger one, you can use Docker BuildX or Docker MCP toolkit to make changes, or you can also continue to use your own favorite development tool, Eclipse or IntelliJ or Visual Studio Code, based on the need, based on the runtime, based on the application programming language stack. You can use whatever tool you want. And Docker has extensions. Currently, you can connect it with Kubernetes. You can connect it with visualization tools like Kibana or Grafana. You can also connect it with the entire Docker containers can be managed as a code using Terraform, and even Docker can be integrated with VMware, all those things. And if you want to connect to a database, let's say Microsoft SQL or Oracle, or if you want to connect to a different third party MySQL or different database, Docker can also be integrated. It has extensions to connect to all of them. So Docker has even recently added one more architectural new tool called Docker VMM, which is a Docker virtual machine manager tool. Okay, so that is mainly for managing the resource utilization, container startup. See, Microsoft had its own product called System Center Virtual Machine Manager. So it's a kind of see, Docker also have to evolve on the other side. They cannot just restrict them only on the containerization alone. As I told you earlier, so virtualization is also being used on, see, currently it's like virtualization as well as containerization. So containerization on top of virtualization. So if Docker has to have more control, they also have to have their own product. So that's where they introduced Docker Virtual Machine Manager, Docker VMM, through which you can also manage and maintain not just the container alone, even quite a lot of resource sharing, resource utilization, and those additional things can also be done at one more layer down. Okay, so Docker is giving you the option for the developer to do changes as you like on your own set of tools. But if you want to do the modification, debugging, changes, and stuffs using Docker native tool, you can also do it. And with Gen AI and other AI evolution, they are also coming up with quite a lot of additional enhancements and stuff. And I will also share the Docker Sandbox, which is a very good tool, using which also you can do some kind of experimentation, changes, and other things. There are some features within the Docker Sandbox as well. Okay, so there are many products. Okay, so here I have just listed only the component which are very applicable for us. So I have listed the Docker Desktop, Docker Hub, Docker CLI, and there are few more tools like Docker Compose, which is for multi-layer application development and building. And they Docker has a tool called BuildX, and they also have a tool called BuildKit. They also have a separate tool for cloud also, Build Cloud. Docker has more product, and which is purposefully, I mean, which is mainly for developers, application developers to develop the container. And Docker Scout is for security, and Docker extension, Docker Sandbox, Docker VMM, Docker Debug. There are quite a lot of other products which you can find from the Docker official portal. Is it okay? Is it clear, SP?
Yes, sir. Yeah,
Okay.
thank you.
Okay, so Docker architecture. Now we need to get into the each and every component of stuff. We are at 12:30. Okay, I have to step out around 1:10. Maybe we'll see like how much we can cover today. So tomorrow it will be a detailed session where we will see how to install Docker, what are the commands that we use. Maybe like tomorrow it will be completely practical. Today I know it is little bit dry because of the complete theory. You need to understand this theory before we get into the practical. So tomorrow it will be mostly fully practical session, and you won't feel this dry to understand it. Okay, so let's continue and complete as much as possible today. And see, these are the 5 important object you need to understand from Docker perspective. So Docker image is a packaged product where you can store it in Docker Hub or Docker registry, and whenever you need it, you can fetch that image, pull that image, and run it as a container on the Docker daemon, on the Docker server, right? On the Docker engine, you can run the container. When it is stored as a package, it is called image. When it is running as a system, as an application, then it is called container. It's the same thing, okay? But while it is running, it's called container. While it is stored, it is called image. And Docker file is where you mention what kind of things you need for your application. So whether you need a specific front end application or back end platform, whether you need specific database, are there any dependencies you need to install. So I'll show you how to create a Docker file from the scratch, how to layer it, and how you can add caching and other things within your Docker file. So Docker file is an instruction where you inform how to do the step-by-step packaging and unpackaging of your Docker file and Docker images. So it's a tool instruction document where it has all the clear instruction of your complete recipe. See, I can just give an analogy, right? See, for example, you are getting the same meat, the same what do you call additional ingredients, but then the taste is different in hotel or in a different restaurant or whatever, right? So they have their own recipe. And these days you are also I think there is a quite a lot of online option where you can purchase the entire recipe itself, right? Where they have the meat along with the ingredients and the special things, they package it and then they sell it in the online platform. So you might get similar taste because they are completely giving you the recipe. Similarly, here developers, they add whatever is needed for the application to function to the fullest, to give the same kind of experience for the end user. So they add everything, they package it, they layer it in a way that the complete application gives the same experience for every single end user. So Dockerfile is where you actually construct it. It's the recipe on how you add and what is needed, which library is needed, which runtime stack is needed, what kind of patch is needed on the OS. So all those clear instructions are actually given in the Docker file. We'll show how to create the Docker file. It's the same standard name that we will use to do that. So volume is for storing the content. So for example, if you want to store something or upload something or store some log and other things, we will add a volume, and we will also see how to do it. And we can also have a separate virtual network for your containers. You can also have separate network interface for your containers, and you can assign IP address. You can have separate traffic for each and every container. So these are the 5 objects that we need to understand while you are getting into the practical stuff. So the Docker image, the very first one, right? It's just a kind of pre-packaged thing which has your application, and also it has its own runtime stack. It will add the node, or it will have the python or java or whatever runtime you need, it will be there. And whatever instructions you need to do, right, whether you want to copy it to a particular folder, and whether you need to install any additional packages or libraries, you will give all those instructions and stuff in your Docker file. And once it is all done, you will just create it as a image, and once the image is ready, you will push it into the cloud platform. So I think when we get into the practical mode, you will start understanding this much better. And these are some of the 3 feature that the Docker as a product they use. The Docker daemon relies upon 3 important Linux level features. The reason I'm saying it, see, for the AWS, for the cloud platform, you don't have to worry in the cloud platform, because the underlying physical hardware, underlying physical host operating system, including the Docker, it comes as a service. So Elastic Container Service, ECS, is a Docker container as a service. So even the Docker daemon is also being managed and maintained by Amazon AWS team. So you don't have to worry on AWS side. But if you are managing it on your own, or if you are doing it on your on premises, right, let's say you have the entire control of the environment, the containerized environment, and you need to take care of it. So you need to have the understanding of these things. So there are namespaces, control groups, C groups they call, and then you also have the union file system and all those things. So these are all some areas on your premises. If you are running the complete Docker stack or the container environment, you need to understand how the process ID works, how the mounting works. And because, like, whenever you are not able to access the volume, you need to go and run some mount command. And if there is some spike of usage, you need to know how to manage those process IDs, how to manage those process, how to connect to a network port. And you need to be aware of some of the standard commands, right, like netstat or ifconfig and those commands. So all those Linux related aspects are leveraged for your containerized environment. So you need to have some basic idea about namespaces, and you also need to have some idea about how the resources are being shared, because the control group is a C group is a feature where it will share how much CPU you need, how much memory you need, what is the minimum, what is the maximum limit, how much percentage the container is currently using. So all those report, it comes from the C group, the control group feature. It is a Linux native feature. And for the file system, right, so that's where you store the image, access the files, store the secret. All those things are managed from the file system. So file system management is also something you might have to learn if you are going to manage the on premises environment. But cloud, you don't have to really worry, it is managed by AWS team. But you need to have some basic understanding that there are 3 important Linux feature which runs your container in a more efficient and secure and uh, controlled manner.